In this video, we will cover cross-tabulations and calculating percentages for these tables. For this example, I will use the data for problem number 28 in Chapter 2 of the textbook. For this question, a sample of respondents was asked their opinions of bilingual education and affirmative action. The responses are given in this cross-tabulation. The first thing that I'm going to do is calculate totals for this data. So I will click on the Insert Function button, select Sum, and select the appropriate cells. I will then click on the lower right corner of the cell and copy it over into the opposed column. This gives us the column totals. I will then do the same thing for the row totals. I'll select the row that I'm interested in and then copy that into the opposed row as well. These totals are referred to as marginals. That is, they are on the margins of the cross-tabulation. I also want to calculate the overall total number of respondents. And I can do this in a number of ways. Using the sum function, I can either select all of the cells in the table, or the row totals, or the column totals. Either way, we see that the total number of respondents is 211. Now, there are three different ways that we can calculate percentages for cross-tabulations. We can calculate total percentages, row percentages, or column percentages. The first way that I will demonstrate are total percentages. So I'm going to create a number of extra rows in order to place my percentages. So I will click on row 4 and then right click and select Insert. I will also select row 6 and insert a row between row 5 and 6 as well. You'll notice that I created borders around the original data, and I'm going to clean these up a little so that it's clear which percentages are associated with which frequencies. Okay, the formula for percentage is 100 times the frequency divided by n, or the total sample size. When we calculate total percentages, the n is always the total sample size, or 211. So for the cell with people that favor both bilingual education and affirmative action, the formula is equals 100 times the frequency of the cell divided by the total sample size. And we get an error. Why do we have an error? Well, if instead of trying to calculate a percent, I enter some number, you'll notice that both the column total and the overall total change. So what's happening? If we double click on this total, you can see that Excel automatically updates the formula to include the rows that we inserted. There are a number of ways to fix this. The best way is we can copy these two cells, the total cells, and then paste them back in as values instead of formulas. So I'll copy the cells and then right click and select Paste Values. You'll notice they're the same numbers. However, if you double click, you can see that now there is a number instead of a formula. We'll do the same thing with the row totals. And now, when we enter our percent formula, that is 100 times the frequency divided by the total sample size, we get the percentage for that cell. Now I want to copy that formula into the adjacent cell, so I will place $signs in the denominator so that when I copy the formula, it does not move from the total sample size. I will then do the same thing for the oppose row. So the percent of the sample that favors bilingual education but opposes affirmative action is equal to 100 times the frequency of that cell divided by the total sample size. Again, I want the formula to stay with the total sample size, so I insert $signs and then copy the cell over to the opposed column. Now, I'm going to create a marginal percent column and row as well. So I'm going to sum the percents for favor as well as the percents for oppose, affirmative action, and then do the same for the columns. In this case, instead of clicking and dragging, I will simply select, by holding down the control button, the two percentages in the favor column. Now you'll notice that the percent total marginals for the columns sum to 100%, and the percent total marginals for the rows also sum to 100%. With total percentages, we can answer the question, what percent of the sample? So, for example, we can say that 38.39% of the sample favor bilingual education. 57.82% of the sample oppose affirmative action. These percentages utilize the marginals. We can also utilize the percentages within the cells. So, 26.54% of the sample favor both bilingual education and affirmative action. 11.85% of the sample favor bilingual education but oppose affirmative action. To reiterate, if we want to answer the question, what percent of the sample, total percentages are most useful. However, there are instances, particularly when we have independent and dependent variables, where row or column percentages are more useful. Here is the same cross-tabulation with the percentages deleted. If we want to calculate row percentages, what we are doing is essentially treating each row as a distinct frequency distribution. The difference when we calculate row percentages is that instead of using the total sample size, 211, for n in our formula, we will use the row totals as our n. So, for those that favor affirmative action, the percent that favor bilingual education equals 100 times the frequency in that cell divided by the total for that row. Similarly, for those that oppose bilingual education, the percentage equals 100 times the frequency for that cell divided by the total for that row. When we calculate the percentages for those that oppose affirmative action, that is this row, we'll use 122 as the n. So for the percentage that favor bilingual education, our percentage is 100 times the frequency in this cell divided by the row total. If I add dollar signs to the denominator, I can also copy this cell into its adjacent cell. If we then calculate percent total, we can see that the row percentages sum to 100%. However, the column percentages do not. The purpose of calculating row percentages is that it allows us to compare the percentages between one row and the other. So we can say that 63% of those who favor affirmative action also favor bilingual education, while only 20.5% of those opposed to affirmative action favor bilingual education. Column percentages are calculated in much the same way. However, instead of using row totals for our n, we use the column totals for our n. So, for those that favor bilingual education, 100 times the frequency divided by the column total favor affirmative action. We can copy this cell into its adjacent cell. For those that favor bilingual education, 100 times the cell frequency divided by the column total oppose affirmative action. Now, if we sum the percentages, we see that the rows do not sum to 100%. However, the columns do. Column percents are useful when we want to compare percentages between responses on the column variable. The decision whether to percentage rows or columns depends on which variable is the independent variable. Generally, we percentage based on the independent variable. So, if instead of bilingual education, the column was based on sex, males and females, sex would be the independent variable. That is, one's sex determines whether one favors or opposes affirmative action. We percentage based on the independent variable. Since our independent variable is the column, we calculate column percentages. So in this case, we could say that almost 70% of males favor affirmative action, while only 25% of females favor affirmative action. To summarize, total percents answer the question, what percent of the sample? Row percentages answer the question, what percent of the row? For example, what percent of those that favor affirmative action? Or what percent of those oppose affirmative action favor or oppose bilingual education? Column percentages answer the question, what percent of the column? In this case, what percent of males? Or what percent of females favor or oppose affirmative action?